What's going on, everybody? We're going to talk about using an angle, applying a force at an angle. All right, we did this a while ago, but let's talk about it in reference to force, or work, excuse me. Let's say we got 20 kilograms right here, or 2 kilograms right here. 2 kilogram weight, all right? And we'll say that. Boom. And we'll call this right there. You go 5 meters. You go 5 meters. The 2 kilogram weight, and we'll say you did 20 newtons of force this way. We'll say your angle is equal to 30 degrees. All right. So really, what's happening here? Let's look. If you just pull this straight up and down, what is that? That's the weight, right? It's just 2 times, it's just mg, right? It's 2 times gravity, so it'd be about 20. If you just pull it side to side, that's the easiest, right? That's just sliding it across something, that's the easiest way. But if you're doing it like this, if you're pulling up and you're pulling to the side, well, you have the y and the x acting on it, right? And so right now, all it's doing is moving to the side. It's not going up at all. But you're applying 20 newtons of force in a resultant vector, okay? And we remember that from the other, from like momentum and everything. The resultant is because of 2 different vectors. For this one, it's the y vector and the x vector. That gives you this resultant vector. So we have an angle of 30 degrees, all right? And you're applying 20 newtons of force over a distance of 5 meters. Now you, the person who's pulling it, you feel like you've done 20 newtons of force over 5 meters, right? And so you feel like you've done 100 newtons of force. But what if you actually, or 100 newtons, or 100 joules of work. 20 newtons over 5 meters. So you feel like you've done 100 joules of work. But what work did you actually do? What work did you actually accomplish, right? When we talk about work, we mean like displacement and everything. So if I was to lift this up but then put it back down, I put energy into it, but I didn't accomplish anything. I did not accomplish any work. The same rules apply to this one. You feel like you pull it with 100 joules, but what did you actually, like what was the work you actually get credit for? All right, so you have both a y and an x. So how do we take into account this angle? Well, we're not moving in any way in the y direction, all right? So we don't have to worry about that. So how do we get from here to there? Well, this is our adjacent leg, so we're going to use cosine. Because remember, cosine of the angle is equal to the adjacent over the hypotenuse, all right? And our 20 newtons, our resultant, that's our hypotenuse. Here's our A, so we're just going to multiply by h. And that makes a lot of sense. So now we really can write our formula like this. We can say work is equal to whatever force you applied multiplied by the cosine of the angle multiplied by the distance. So that's your work. That's the work you actually accomplished. So in this case, if we were to multiply our force, 20 newtons, and put it in the x direction, say 20 times cosine of 30, and then we're going to multiply that by 5, we actually get the work accomplished equal to 86.6 joules. So for these questions, what's the work you actually accomplish, not the work you think you do? That's the difference between these. It's, you feel like you're doing more work than you actually are, essentially is what's happening. So try these problems. I think you guys will be good at it.